Hello everyone, so in this video I'm going to be talking about binary. So what is binary? The short answer is it kind of depends. A lot of you are going to have assumptions about what it is because of what you've heard from like TV shows like CSI Miami, which by no means you should listen to anything on there. Half of their facts are pulled out of some God-forbidden place that I don't know, they have like monkeys write their scripts or something. A lot of the stuff that they have to say about computers are all wrong, but that's another discussion. Anyways, so what is binary? Well, the answers you don't want for it are, it's a numerical system. It's not a programming language. It's purely just a mathematical numerical system, just like the decimal system that you use to count. Binary, by the name binary, means that there's only two digits. You have a 0 and a 1. That's the famous like 0, 1, blah, 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 that people always think of. It's because there's only two digits in binary, 0 and 1. In the decimal system you have 10, 0 through 9. 10 is not a base number of the decimal system. And then it allows us to store information with only two options. It's very compact. We don't have huge amounts of different ways of storing them. If there was an easy way to do it that we were able to use, which is basically what quantum computing is attempting to do, we would probably use it. Your hard drive, for example, has metal platters on there with little magnetic pieces, and the poles on those are ones and zeros, the positive and negative. On your hard drive actually stores the information in binary. But by no means is it a language. It's purely just a system. A language would mean that it's actually something that's communicatable. Binary is just a system of numbers that your computer and people long ago used to create programs because it was just the simplest way to communicate with your computer. I kind of already dove into this. How does it apply to computers? Well, your CPU reads binary and it writes binary. And by writing binary, I mean it'll take binary in, and when it processes the numbers, all results from the CPU are sent out in binary as well. Binary is the most basic instruction to your computer. There's nothing underneath binary as far as what your computer uses. Except it's not actual numbers. You're talking about high and low charges of electricity being sent through, which your computer understands as positive and negative, or 1 and 0. It's a very simple way and accurate way to store data. There's really no there's nothing that is really complicated about it. You have a 0 and you have a 1. Depending on the implementation of your CPU, the binary may be different. That's why you can't just program in binary nowadays. You don't know what CPU someone's using. If you've ever heard the term compiler, if anyone out there learned C, I have a few videos on that as well. A compiler will take your C code, which is actually a high-level language, convert it into assembly, link the assembly, and then convert all that into binary for your specific CPU, because it has to be created specifically for it. Otherwise your CPU will not know what to do with it. And 1 byte of data is 8 binary digits, which means that 1 gigabyte is a lot of binary digits. People always say, oh wow, he has a terabyte of data. The amount of zeros that is gigantic, and it kind of will blow your mind when you kind of think of it this way. 1 byte is 8 binary digits. That means 1 kilobyte is 1,000 bytes, which is 1,000 times 8. That's 8,000 just for 1 kilobyte. That's a lot of information. Back in the day, they only had 256K RAM. That's what I believe. That's the amount that was quoted by Bill Gates, saying no one would ever need more than that. Now we have, some people have over 16 gigabytes of RAM, which is just a ridiculous amount of data for how much you can actually store in that. And later on we'll actually get to what is the significance of 8 binary digits in modern times. So this is the slide. Modern examples of where you would see binary, because of course you're not going to see it every day. Even if you are a programmer, you're never going to program in binary unless you're just doing something on your own. It's not practical. You'd be stupid to do it. There's no practical application to using binary anymore. But there are a few places where you will see it. It's still the most accurate way to convert between character sets, and what I mean by that is that if you try to convert something from ASCII, which is a character set which just has basically the characters on a standard QWERTY keyboard that you'd find in America, and then you have others like UTF-8, which are Unicode. Those ones are going to have many more characters. If you try to convert something from UTF-8 to ASCII, you're going to lose characters, but if you convert them into binary, you will actually still maintain the same information and it won't be lost by trying to convert it into ASCII. It's still used to communicate to your CPUs. There's really no other way of getting around that. Your computer uses binary. Modern computers do, even supercomputers. There's no like secret that the government, as far as we know, has done about making some supercomputer that doesn't use binary. Storing information on a hard drive, we already talked about this a little bit too. You have your metal platters, some magnetic bits, and then a little like arm that flies over really fast with a copper wire attached to the bottom and 2 magnets at the base, and it just flies over and arranges your bits on your platter. And then here's some miscellaneous information. So 1 byte, or 8 bits, stores 1 information. In the ASCII character set, 01000001, I believe that's 8, yeah, is equal to a capital A, and they actually follow in sequential order. I don't really want to go over how to count in binary right now because it's not that important. Basically, learning binary isn't that important, but it's kind of nice to have a kind of a background on what it actually is meant for and what it actually means. But there is actually a way to count for it. If you took this 1, made it into a 0, and made this 0 into a 1, you'd go up 1 number in the binary set, and this would be a capital B instead of a capital A in the ASCII character set. Very important that you pay attention to what character set you're talking about. Unicode uses different amounts of binary digits for each implementation. So you have UTF-8 and UTF-16, and that 8 or 16 actually tells you how much data you're storing for each character, which means UTF-16 is going to store twice, or not twice because it doesn't work that way, it's going to store an immense more amount of data than you're going to store with ASCII or UTF-8. Individual binary digits are referred to as a bit or bits because you're not going to just say like binary digit a bunch of times. Bit is just your unit that you use for binary. Each one of these numbers up here is 1 bit, and it takes 8 of them to make a byte. And so that's the end of the video. If you guys liked the video, please press the like button. If you want to see future videos, subscribe. And if you want to see all my other videos, I have a website called lawofcode.com, which has all of my videos, a smaller feedback section that I check daily, which is going to probably be a very easy way to contact me or give me feedback, as well as the comments section below, and you can always PM me on YouTube. If you guys have any questions or comments, leave them in the comment section below or on the feedback page on lawofcode.com. And other than that, I will see you guys next time. Thanks.